Okay, students, you have finished almost the syllabus. Left with two lessons, that is, three-dimensional shapes and your rotation, reflection, and symmetry. See, children, this three-dimensional shapes is a different subject altogether. Here, mathematical concept is more conceptual based. You see the object in around you, and from there, there are some aspects of those objects you are supposed to know. See, I'll tell you first of all, you have learned in geometry some of the plane shapes, some of the plane figure you have learned in geometrical figure. See, most of the geometrical figure having length and breadth, two dimension, isn't it? Now let us discuss on all these things. See, I have drawn few of the figures. See, this side, the blue color drawing is indicating you the sum of the geometrical figure. This is a rectangle, this is a square, this is a triangle, and this circle, and this is a pentagon like figure, isn't it? This all doesn't have any breadth. Does it have a breadth? No, it has got, what are the two dimensions? It has got two dimensions. The dimensions are length. It has got, all the object has got length and breadth. It has got some breadth also. That means it has got two dimension length and breadth, all this object, isn't it? So that is why it is called 2D object, 2D figure. We say, we don't say it as solid because it doesn't occupy any space. Now moving on to the other side, you see black color, all the figures are, these are having some length, some breadth, some breadth and some thickness. It has got length, breadth, the height and thickness. So we see along with the two dimension length and breadth, if you add, height, length, breadth and height, this all geometrical figure will be there. So see, in this case, no, there are rectangles. Here is one rectangle, back side similar rectangle, front side another rectangle, this side the same rectangle as this, and then top is one rectangle and bottom is another rectangle. So combination of rectangles. Here combination of square. Here one circular region and another is the conical in shape. See, like this, there are figures there are geometrical objects which is called three-dimensional solid because it has got length, breadth and thickness. Why do we call it as solid? What do you understand by solid? Solid means any geometrical figure which will occupy some space. If you keep any solid object on a plane surface, it will certainly take some space. That is why they are called solid. Whereas this 2D object doesn't occupy any space. This has, this has already got two dimensions. In front of you see the blackboard. If you look, the blackboard of course has got some thickness, but if you see the front view of the blackboard, it has got length and the breadth. Two dimensions are there. Could you understand? So like this, in front of so many objects are there. I will tell you, if you take this scale, see this will certainly occupy some space. So it has got some surface, two plane surface and one curved surface. So this is a cylindrical object. Like this, if you take like this object, see this face, top face is equal to the bottom face, this side face is equal to this face, and front face equal to the back face. So it has got 6 faces. Like this object is cuboidal object. This is cuboid. This is a cuboidal object. Similarly, if you take an ice cube, you will find all the faces, all the front face, the back face and the side faces, top face and bottom face, all will be equal. They all will be in square in shape. That is called cubical object. Like this conical object, you take ice cream cone, the cone part you take it, that will become conical in shape. It will have one flat surface, one curved surface, and it will have a corner as well. So conical object. Like this, if you take a ball, if you take that ball, see, the ball will have only one round surface, no edge, no corner, isn't it? Ball will also take some space, but with its curved surface. Could you understand? Like this, this is what? This is a cylindrical object. Okay, like this, there are solids in and around. If you see the door, here also it's a solid because it has got rectangular shape, and that will be semicircular one cell will be there. You will take a bowl, that will be a semicircular hemispherical cells will be there inside. These all are called solids because it has got 3 dimension length, breadth and height. I hope I have understood. Then another 2 objects I have taken here. See here, this figure you see, here is a, you can say it as a, this is a prism. This is a prism, this is a pyramid like shape. This is a prism and this is a pyramid. What do you understand by prism and pyramid I am going to tell you later. These all are the solids, 3D solids, 3D object having length, breadth and height or width. That is why it is called or thickness or depth. That is why it is called 3D object, and these all are 2D object. Now see, can we have 1D object? What does it? It's a line. Line is having only length, no breadth, no thickness. So therefore line is an example of 1D object. So we can have 1D object too. Now we'll be learning about 2-3 aspects. First of all, what do you understand by first of all you understand by polyhedron or polyhedra. See, do you understand polygon? A line is plane figure bounded by more than 3 or more line segment. They are called polygon. Similarly, polyhedron or polyhedra will be a solid figure bounded by 4 or more faces. 4 or more faces. This is a face. This is a face. This is a face. This is a face. That side is a face. This side is a face. So it has got 6 faces. 1 face, 2 face, 3 face, 4 face, 5 face and 6 face. So any solid which is having 4 or more faces, they are called polyhedron or polyhedra. You must know the definition. Could you understand? So this is a polyhedron, this is a polyhedron, polyhedra, polyhedron. Could you understand? Like these figures are there. Now I will be talking to you about 2 aspects, that is called prism and pyramid. What do you understand by prism and pyramid? So prism is what? First of all, prism means you see this object, you see here ABCD is the base. ABCD is a quadrilateral. You can say it as quadrilateral or say it as parallelogram. Could you understand? Assume it's a parallelogram. Now this ABCD top face is also similar parallelogram. Same parallelogram, same means these two will be congruent, you can say it very well. Now these two are same base and side face where it is a rectangle in shape. When side faces are always will be a quadrilateral, rectangular in shapes, they are called prism. Could you understand? See the side face. See this face is side face. This is 1. See, this is 2. Then this other side 3 and 4. 3 and 4. 4 sides are there. That 2 sides you can very well assume it alone. So this is a prism. Prism means prism can be triangular prism also. The top face will be, see here is an example of triangular prism. Top face and bottom face is a triangle, we say A, B, C and A1, B1 and C1. These two are triangle, but the side face you see, side face is a quadrilateral in shape. So that is why it is called prism. That means whose side faces are a quadrilateral in shape, they are called prism. Some solid whose side faces are quadrilateral in shape, they are called prism. Okay, if this all rectangular in shape, all the side faces are, then they are called right prism. Right prism means top and bottom surface if they are rectangle or a square shape. Other faces as it is has to be a parallelogram or a rectangle. That's what they are called right prism. I hope you have understood the concept of prism. This is also prism. This is a triangular prism. Prism will be classified as per the front face and bottom face. First face and bottom face will be identical in shape. In this case you see triangle, in this case you see quadrilateral. So this is what prism. This is a right prism or a rectangular prism. You can say it as. Could understand rectangular prism. Could understand. But this prism is called a triangular prism because top face and bottom face is in the shape of triangle. Could understand it. Now moving on to pyramid. Pyramid means the base has to be a triangle. The base is a triangle. Side face has to be a triangle. Here the side face was a rectangle, or could understand. But here the side face has to be triangle. You see the side face, it has got 3 side faces, and all the side faces will be drawn to a common vertex. Here is a common vertex. See, this is a triangle, this is a triangle, and front is also a triangle. Could understand? So all the side faces will be drawn into a common vertex. That all will come in a common vertex, that is called pyramid. Could you understand? See, here is a pyramid, but these two pyramids, can you find out the difference? This is a rectangular pyramid because the base is a rectangle. Here the base is a triangular pyramid. This triangular pyramid side face is a triangle. Could you understand? Now this is pyramid. Now I will tell you about what is called tetrahedron. Tetrahedron means a pyramid. Pyramid you could understand the classifier, and then a triangular pyramid is called tetrahedron. This is a tetrahedron pyramid because its base is a triangle, and then it has drawn all the side faces has come into a common vertex, and it has taken the pyramid shape. But as the base it is classified as it is a triangle, it is called tetrahedron. Could understand? Now this is a rectangular pyramid. Like this pentagonal pyramid can be, their base will be a pentagon. Like this hexagonal pyramid will be there, base will be hexagon. Okay, prism will be classified with the top and bottom surfaces as the shape it is, and pyramid will be classified with its base only. Could understand? Base, if it is triangle, it will be triangular prism, and pyramid, and base it is rectangle, it will be rectangular pyramid, and so likewise. Now I will be talking about Euler's theorem, which is very very important in this 3D object. See, I will tell you first. See in this object you take. See, these all are what? I will take this. It will be better. These all are what? This is an edge. This is another edge. This is another edge. This is another edge. All that is called edge. This polyhedra will have how many edges? First of all, how many faces? Front face, back face, side face, both the side faces, both the top one. 6 faces. A cuboidal object or cubical object will have 6 faces. 6 ways it can occupy the space. Face or surface means a solid. The solid which occupy the space is called face or surface. So it can have 6. Like this, how many corners? 1, 2, 3, 4, 5, 6, 7, 8. It has got 8 corners. See, 1, 2, 3, 4, 5, 6, 7, and 8. 8 corners. It will also have 8 corners. Could you understand? It will have edge. How many edges? It will have 12 edges. You see, 1 edge, 2 edge, 3 edge, 4 edge, 5 edge, 6 edge, 7 edge, 8 edge, 9 edge, 10 edge, 11 edge, and 12 edges. It will have 12 edges. I will show you once again. 1 edge, bottom one, 2 edge, 3 edge, 4 edge. Now you just go to the other side. You will find 5 edge, 6 edge, 7 edge. If you go 8 edge, 9 edge, 10 edge, and you will have 11 and 12 edges. It will have 12 edges. Could you understand? So it will have 12 edges. It will have 12 edges. This one will have 12 edges. Take about cuboidal. It will have 12 edges. It will have how many corners? It will have how many faces? First of all, 6 faces I said to you. And how many vertices? Corner or vertices will be how much? Will be 8. Now Euler's theorem for Euler's theorems for tetrahedron, polyhedron will be a plus b minus e is equal to 2. Anything, if it is a pyramid also, if it is a prism also, if you calculate this, it will be always coming to a plus b minus e is equal to 2. That's very, very important. See, in this case, see, you just do this for a cuboidal object. Edges are 12, faces are 6, vertices are 8. Now, if you do it, a plus b is equal to f is 6 and v is 8. If you do the addition and do the subtraction with 8, you will find always 2. So 2 comes. So Euler's theorem is a plus v minus e is equal to 2. That is Euler's theorem for polyhedron. Could you understand? If it is a triangle, suppose this is a triangular prism it is. So how many edges you see? How many surfaces? 1 surface, 2 surface, 3, 4, 5 surfaces, isn't it? It will have how many surfaces? 1, 2, 3, 4, 5. Triangular prism will have 5 surfaces. So 5 surfaces, how many edges? 1, 2, 3, 4, 5, 6. See, triangular prism, you can very well implement Euler's theorem by, it will have how many faces? You said 5 faces. Faces will be 5. Now it will have how many edges? I said to you, it will have 9 edges, because 1, 2, 3, 4, 5, 6. A triangular prism, triangular pyramid, triangular prism will have 5 faces, 9 edges. 9 edges will be 1, 2, 3, 4, 5, 6, 7, 8 and 9. Edges will be 9. And how many corner? It will have 6 corner, I think. It will have 6 corner only. Vertices will be 6. If you implement this Euler's theorem, it will be a plus v. 5 plus 6 is how much? 11. 11 minus 9 is 2. So Euler's theorem will be implemented for every type of polyhedron. Could you understand? Now moving on to isometric draw. How will you draw the figure? It's very simple. If you want to draw, see, isometric draw is what? Have you seen the graph sheet? Graph sheet, it will be the combination of small square and it will form a bigger square and so. So likewise, isometric dots are, all the square dots are there. Here, if you know the pattern how to draw a particular figure, suppose I will draw this particular figure. Let me see whether I can draw it now. 3 dot you take. 3 dot of the isometric dot block you take. I have taken from the center only. This is a square, you say. Okay. Now from the center, again 3 dot you connect. All 3 dot, because it's I have taken a very simple example. Now you connect this all edges. See, you will have this figure. So isometric dots you can have all the polyhedron drawn. Okay, now exercise you have to do that can be done very nicely, especially Euler's theorem.